All right, welcome back, people. So today is all about the distributive property. Okay, this is one of the more important properties or rules that we use in algebra. Um, so before I get into it, think of this word distributive, right? Or to distribute something. Think about how I might use that or how you might use that in the real world, right? um, you want to think about sort of passing something out, right, to distribute it. Like I might distribute permission slips for a field trip, right? Okay, so the way we use this in math, basically it helps us solve expressions in this format: a parentheses b plus c. Okay, a parentheses b plus c. Sometimes this is called the distributive property of multiplication because this A gets distributed to everything inside the parentheses and the operation is multiplication. So um, let's look at an example of that. So if we were going to look at this same format, right? 3 3 parentheses 2 plus 1. How could we simplify that expression? Well, if you remember PEMDAS from maybe 6th, 5th, 6th, 7th grade, the P stands for parentheses, right? And so if we were going to do this straight up kind of old school, you would do what's inside the parentheses first, which is 2 plus 1 equals 3. And then after PEMDAS, there's no exponents. Oh, next, multiplication. Well, we know that parentheses, this means to multiply. This says 3 times 3, which equals 9. Okay, so this is simplifying the expression using PEMDAS. This is simplifying the expression using the distributive property. Okay, 3 parentheses 2 plus 1, or 3 times 2 plus 1. When I distribute, I call this double rainbow because they kind of look like rainbows. And what this teaches you is that this 3 doesn't just go to the 2, but it gets distributed to everything inside the parentheses. In our world, oftentimes it's going to be 2 objects in the parentheses, so that's why I call it a double rainbow. But even if there was a third number, that 3 gets distributed to every single thing inside the parentheses. So this simplifies to 3 times 2 plus 3 times 1. That's our first rainbow. That's our second rainbow. We can simplify this further. This is multiplication, right? 3 times 2 is 6. 3 times 1 is 3. Okay? 6 plus 3, 9. So you can see using either method, we get the same exact answer. This is going to come in really handy when we start working with variables, right? Letters. And so we're going to jump right into that. What I want you to pay attention to, this is something I didn't cover in the last video on the algebraic algorithm that we talked about. It's this idea of inverse operations, and I wanted to throw it out there to make sure you got it in your notebook. So make sure you add a big bubble around this, but this is one of the more important key terms. So you're going to hear me talk a lot about inverse operations. What does that mean, right? So inverse operations is basically the opposite operation that undoes itself, or that opposite operations that undo each other is basically the definition as it's written. Okay? Operations are things like multiplication, division, subtraction, and addition, right? And then we're going to talk about exponents and square roots later, right? Okay, so a T-chart that might help you understand this looks like this. Okay, so we have our operations and we have their inverse. Okay, so what undoes addition? Well, subtraction. What undoes subtraction? The opposite, addition. Opposite of division, multiplication. The opposite of multiplication is division. So when you see these operations in a problem, the inverse is the opposite of that. Yeah? Notice how I used a dot and a slash to model multiplication and division. That's going to be more common for our notation. So this slash is the same thing as like a line for a fraction, right? Okay, so I'm going to cut this video off here. The next video, we're going to start doing some worked examples.